Hi, this is my lab 1. So the purpose of this lab is to make observations about the interactions between two pieces of charged tape, and I'm going to be comparing the experimental results with the interactions in a computational model using ClosScript to predict the charge of the tape and the number of excess or deficient electrons on it. As a preview of the results, I found that the positive charge on the tape would repulse another positively charged piece of tape, and additionally, the electric charge was able to be calculated and it was deficient of electrons. So using GlowScript, this lab uses fundamental physics principles to model the interactions. So these principles include Newton's second law, which explains how the acceleration of an object is proportional to the mass of an object and the net force acting on it. Additionally, Coulomb's law is essential to this lab as it describes the strength of the electrostatic force between two charged objects, whether it's attraction or repulsion. The electrostatic force is equal to the charge of one object times the charge of another, divided by the distance between the two, squared, all times the Coulomb's constant, denoted by PHYS in GlowScript. So in the experimental model, the system was tape B while the surroundings was tape A, and these were stated in the instructions. So for each piece of tape, the mass I had was 2 times 10 to the negative 4th kilograms, and the length was 0.2 meters, and the width was 0.02 meters. For this model, I had to assume that each U-tape had the same net charge. Similarly, I assumed that each tape has all of its charge located at a single point at the center of the tape. And doing this reduces the problem's complexity, and it allows us to make calculations as if point charge B is just floating above point charge A, separated by a distance d. And also I ignore air resistance. So here you can see our results of the experimental model. I found that the U-tape repelled another U-tape with the separation distance 0.025 meters. The U-tape and hand were attracted to each other, and the U-tape and pen were attracted to each other as well. And this is because the pen is likely negatively charged because of its interaction with clothing and stripping other charged objects of their electrons. So then from these results, we can see that the U-tape is positively charged. The computational model uses Python and GlowScript to create the theoretical model of the tape again. So in the beginning, I set values for the tape's physical properties, and I also defined electric force. Charges and calculations are needed to find the ratio of deficient electrons to atoms. I divided the number of electrons by the number of atoms, and to do this, I found the surface area of the tape, which is 1 times width times 2 divided by the area of an atom. So the ratio of deficient electrons to atoms is 6.94 times 10 to the power of 10 divided by 3.42 times 10 to the power of 17. For electrical charge of a single tape, I also used Coulomb's law and the formula for the electric field on a point charge to find the tape's weight, where the force of gravity on the tape is its equivalent. So the charge of a single tape was thus 1.2 times 10 to the negative 8 coulombs. So just to go over the results, the tape was positively charged, so there's an electron density which affects its interactions with other charged objects like tape, a hand or a pen, etc. The U-tape floats when its net force is 0 and it is at static equilibrium. This is when the magnitude of the electric force is equal to the force on it due to gravity. It's notable also that the magnitude of electric force was 1.7 times 10 to the negative 5, but the gravitational force calculated was 2 times 10 to the power of negative 4 in the computational model, and this discrepancy could be accounted for by inaccuracies in the tape measurement and initial conditions which would have affected the following calculations. Also, the U-tape may not have been held exactly parallel to the other piece, which could have affected how it moved, and there are also very likely loss of charges when handling the tape when moving it near other charged objects, because it will be explained later in the discussion. And also the assumptions that the charges are of equal magnitude in point charges does simplify the calculation a lot and may have led to inaccuracies. So to further think about the physics concepts in this lab, we can look at the discussion questions. So if the electrons and protons switch charges, the electric fields, I said, would flip signs. However, the observed repelling and attracting of the interactions would not switch, since two positive charges switch to two negative charges would still repel each other. For the second question, this is important because charge can be transferred between objects easily when they come in contact with other charged objects. And when this happens, there is a transfer of surface electrons, and thus the charge will change. So this will lead to a decrease in the positive charge of the U tape and affect